Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Euclid division algorithm. Before going to these topics, very first let's have a puzzle. Puzzle time for you. A trader was moving along a road selling eggs. An idler who didn't have much work to do started to get the trader into a wordy duel. This grew into a fight. He pulled the basket with eggs and dashed it on the floor. The eggs broke. The trader requested the panchayat to ask the idler to pay for the broken eggs. The panchayat asked the trader how many eggs were broken. Here the puzzle begins. He gave the following response. If counted in pairs, 1 will left. If counting in 3, 2 will left. If counting in 4, 3 will left. If counting in 5, 4 will left. If counted in 6, 5 will left. If counted in 7, nothing will remain. My basket cannot accommodate more than 150 eggs. Try to solve this puzzle. Better to pause the video, think over it, and later on see the answer. Here, let's try to solve the puzzle. This puzzle can be solved by different ways. Everyone can apply their own approach. Let's try to very first figure out these words. What are these saying? Let's try to solve this. Very first, if counting in, what is the meaning of counted in pairs, 1 will left? The meaning is, if we'll divide the total number of the eggs by 2, 1 would be the remainder. It means the number is not completely divisible by 2, it will leave the remainder 1. So, therefore, if let us consider there are x number of eggs. So, x is equal to 2 times of some number plus 1 remainder. And next line, if we are talking about, it says that if it is counted in 3, means if we try to divide the number by 3, 2 will remain. It means 2 will be remainder. So, we can figure out this as x same number is equal to 2 into some another 3 into some another number plus 2 as remainder. And for the third statement, if counted in 4, 3 will remain. It means x is equal to 4 m, and we have taken, let us consider any other variable, that is L, then 3 will be remainder. If counted in 5, means x is completely not divisible by 5, it will leave the remainder 4. Let us consider 5 into something plus 4 is the answer number. And if we counted in 6, if we are taking 6 at a time, then 5 will be left. It means if we try to divide that number by 6, we will be getting remainder as 5. And if we'll try to divide the same number of total eggs by 7, the number is completely divisible by 7. And we are supposed to find the value of x. Very first we have tried this. So, if we are going to observe this, so it means the number is not divisible by 2, not divisible by 3, not by 4, 5, 6, but it is divisible by 7. It means the answer number is less than 150, as well as this is the multiple of 7. One more thing we can observe out of this, if we'll add 1 in this, then it will become complete multiple of 2. If we'll add in total in 1, it will become the multiple of 3 also, because 1 is less. Same as it will this, if we'll add 1 in the total, it will be becoming the multiple of 4 also, 5 also, and 6 also. It means if we add 1 to that number, it would be divisible by 2, 3, 4, 5 and 6. Do you get any hint out of this? Yes, you are thinking absolutely right. That number would be the multiple of 2, 3, 4, 5 and 6. Then how to find the number which is divisible by all these three numbers? We can take the LCM of these numbers. Now for taking LCM, we need to include 2, 3, 4, 5, 6, because x plus 1 will be divisible by all these 6. If we'll notice that there is no need of finding the LCM of 3 because it is included in 6. No need to find the LCM by using 2 because it is also included in 6. So we'll try to find the LCM of these two. Divide it by 2, we'll be getting here 2, 5, 3. As these are 3 co-prime numbers, there is no need to further thinking of a common factor. So LCM would be 2 into 2 into 5 into 3, and the LCM is 60. It means if we'll count the number in 60 plus 60, then it would be divisible by 2 also, 3 also, 4 also, and 5, 6 also. It means the number of x was 59. But last condition is not satisfied by this because 59 is not divisible by 7. Now how we can think? No doubt a number which is divisible by 2, 3, 4, 5, 6, then its multiple is also divisible by all these numbers. Means we can think of 120 also. 120 but minus 1 because we have added 1 to make the number as multiple of 2, 3, 4, 5, 6. So let's try 120 minus 1, that is equal to 199. Is it divisible by 7? Oh yes, it is divisible by 7. Therefore, we can say that as well as the last condition, it must be less than 150. Our correct answer is 119. Absolutely right. And if you have thought of some another way, you have used some another logic, that also would be correct, no problem in that. So let's try one more way to just see this. Let's see how. The condition will remain same, that is a multiple of 2, multiple of 3, not a multiple of 2, leaving remainder 1. Let's write again. 2m plus 1, the same number is 3n plus 2. It could be 4l plus 3. 5r plus 4, 6s plus 5, and divisible by 7, that is 70. So from here we can observe that it's an odd number. Why? Because it is leaving a remainder. So it means whatever is the answer, maybe it is in 3 digits, but it is an odd number. So it means we have to not to see any number which is an even number. And another thing, it is not divisible by any other property. If you want to notice, yes, I can notice this also. It's a multiple of, if we divide it by 5, then it will be leaving as remainder 4. Means that any number which is the multiple of 5 can carry unit place digit as either 5 or 0. But 0 is not allowed over here, because if we add 4 in this, it will become an even number. It means this is not the condition. It is when we divide it by 5, it must leave remainder 4. It means its unit place digit is 9 only. Now you have to find numbers with which you multiply 7. It will give you a number unit place as 7. Now how many are the combinations over here, so that you will multiply that number by 7, you will be getting unit place digit at 7. And when you multiply 7 by, I think it should be, its unit place should be 7 only, then only we can get it as 9. One option is 0, 4, 9, just because of this 9, but it doesn't satisfy the second condition. If we'll try to find the solution as 49, it will not satisfy the second condition, because 48 is completely divisible by 3, and it will leave remainder 1, but it must leave remainder 2. Let's think of some another number that can be 17. Why? Because we are fixed with this 7 also, because of this condition, and this 7 also because the unit place digit is 9. Now we can have 17 into 7. 17 into 7 is 119. Yes, if we check, this will satisfy all these conditions. Hence, our answer is 190. So, let's go to another way. Now we are introducing Euclid division lemma. Very first, it must be clear what is the meaning of lemma, What is Euclid? What is division? Actually, the lemma is a proven statement used for proving other statements. Actually, lemma is what? Lemma is a proven statement which already have been proved, and is just to be used for proving other statements. And Euclid's division lemma, because it is related to division, and it was introduced by Euclid, mathematician, great mathematician. That's why its name is Euclid division lemma. What it states, let's say, Euclid division lemma states that for any two positive integer, emphasis on positive integers. No doubt this lemma is true for all numbers, negatives also, but we are restricting ourselves up to positive numbers. For any positive integer a and b, there exist integer q and r such that a is equal to bq plus r, a is equal to bq plus r, where there is additional condition that 0 is less than equal to r is less than b. This statement is nothing different. This we have done earlier also in our lower classes as you are doing division. Let us consider we divide any number. Let us consider we divide 47 by 7. So we can divide it as 42, quotient 6 and remainder as 5. If somebody has done it like this, 47 is to be divided by 7 and he has written it as 35, and here he has written 12. 7 5s are 35. So he is saying that we can divide this as this way also, this way also. I think this is, we all know that this is not correct. Why this is not correct? Because there is an additional condition for this, that remainder should be less than the divisor. Here also this is nothing else, this is just the division only. That's why we have written here as division lemma. What is this? This a is equal to means this is nothing else different from dividend is equal to divisor into quotient plus remainder, and remainder should be greater than equal to 0 and less than b. B here is divisor. So here we have studied also, this is all about that we have done earlier also. Now let us consider one more example. Let us consider a is equal to 15, b is equal to 3. We can observe that 15 is equal to 3 into 5 plus 0, where remainder is 0 and quotient is 5. Let's go to Euclid division algorithm. Very first, before going to algorithm, but we should know the meaning of algorithm actually. What is the meaning of algorithm? Actually, algorithm is the series of well-defined this is the series of well-defined steps which gives a procedure for solving a different kind of problem. This you have must learn in your computers also. Algorithm, we have to follow few particular steps unless or until the condition is satisfied. Euclid division algorithm can be used to find HCF of two numbers, or it can be used to find some common properties of numbers. Some special few numbers are there. What is common between these? So for this we'll be using Euclid division algorithm to obtain HCF very first of two numbers. Say C and D are the two numbers and C is greater than D. We have to follow the few steps to find the HCF of these numbers. What are these steps? Very first step is apply Euclid division lemma for C and D. So we find the whole number Q quotient and R remainder such that C can be written as dividend, can be written as divisor into quotient plus remainder. Now we have to do same thing with by considering D as we have to consider D as dividend and remainder as divisor. Same step we have to follow until or unless we will get R is equal to 0. Second step is if R is equal to 0, D is the D means last dividend, last divisor is the HCF of that two numbers C and D. If R does not equal to 0, then apply the division lemma to D and R. D and R means the divisor and the remainder. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. Let's try to solve one example for this. Find the HCF of the given integers 455 and 42. Let's try to solve this. You will be solving this with the help of division very first, so that you can understand this. So very first we'll be taking help of division. Let's how to solve this. 42, as it is a smaller number comparatively, so 455 will be taking as dividend, will be dividing it. 42, remainder is 3 out of this, will be taking 5 here. This is not going, so we'll be taking it as 1 and then 0, 10. Remainder is 35, and remainder, as it is not equal to 0, will be again dividing it. Remainder to be considered as divisor, and the previous divisor has to be considered as dividend. This 42 will be coming here. Now again we have to divide it. 35 ones are 35 and the remainder is 7. Now still remainder is not equal to 0. Process will be repeated. Now 35 will be dividend and 7 will become divisor. Yes, now it is completely divisible and the remainder is 0. Therefore, the last divisor, that would be your HCF. This is your HCF. Now, how we can write this in the way of Euclid division lemma? You can, for initial steps, you can take help of this division, but take care, you have to come to directly Euclid division lemma. 455 dividend can be written as 42 into 10 plus remainder, that is equal to 35. Now this 42 you have to take as dividend is equal to 35 you have to take as divisor into 1 plus remainder is equal to 7. Now again repeat this. This you have to take as dividend, divisor as 7 and 7 5s are plus 0. As this divisor at this remainder is 0, therefore the last divisor, this is your HCF. This is your HCF. Now let's try to let's see this in the type part also for you, so that you can understand this clearly. Now the question is here that how does this method work? So what is happening inside actually? We are dividing it, we are making dividend and remainder, dividend and divisor and remainder as changing dividend into divisor into dividend, remainder as divisor. What is happening inside this? This is the question for you. Try to find the solution for this. Now try one more question. Now just pause the video and try to solve this. Here is the solution. Its HCF is 4. Now next, related to properties, show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1. We need to show this with the help of Euclid division lemma. So, as we have done this, that Euclid division lemma states that a is equal to bq plus r. Here we will be taking any number a, then if we will divide it by 2, there are two possibilities. It can leave remainder 0 also, or it can leave remainder 1 also. Do you agree? Because r should be, what is the additional condition for this? 0 is less than equal to r is less than b. If we are talking about integers, b is 2 here and r should be less than 2. So there are two possibilities only, 0 and 1. So any number if we will consider, it would be of the either of this form or of this form. And from here it is clear, if we are talking, if a number is of this form, it means this is an even number because it is a multiple of 2. And if it is leaving remainder 1, it means it is an odd number. Therefore, odd numbers are of the form 2q plus 1 and even numbers are of the form 2q. Here is the written proof. You can go through that. Next, one more example. Let's try. Show that any positive odd integer is of the form this, where q is an integer. Show that any positive odd integer is of the form this, odd integer of the form this. So here we have seen that this is 4 only, here also 4. So we'll be considering any number as a, let a be any number. Then if we'll divide it by 4, it will be giving you 4 cases. Either it is completely divisible by 4, or it will be giving 1 as remainder, or it will be leaving remainder as 2 according to Euclid division lemma we are talking about, or it can leave remainder 3 if you have chosen any of the number. Now how we can go for this? Let us consider a number is of the form 4q. So it means it is of the form 2 into 2 into q. It means 2 into something. It means this is an even number because it is a multiple of 2. Now let us consider a number is of the form 4q plus 1. It means it can be written in the form 2 into 2q plus 1 is equal to 2m plus 1, where m is equal to 2q. Whatever is here, we have taken 2 common, and this is not completely divisible by 2, it's leaving remainder 1. It means this is kind of an odd number. Now if we'll discuss about this case, if a number is there which is leaving remainder 2, so we can take 2 common, 2q plus 1. It means this is 2 into something, means the number is divisible by 2. This concludes that this number is an even number. And here 4q plus 3 can be written as 4q plus 2 plus 1. 2 common we can take from this. 2q plus 1 is left inside plus 1. Let us consider this to be some variable 2 into something plus 1. It means it is of the form 2m plus 1. It means when we divide it by 2, we'll be getting a remainder as 1. It means it's a kind of odd number. Therefore, odd numbers are of the form either 4q plus 1 or 4q plus 3. Hence, proof. You can see this proof here also, it's written for you. Now on the basis of Euclid division lemma, let's try to understand this. A sweet seller has 420 kaju burfis, 130 badam burfis. She wants to stack them in such a way that each stack has equal number and they take least area of the tree. What is the number of that can be placed in each stack for this purpose? Very first, think about this. What you are supposed to find for this? Take your time, pause the video and think about this. Yes, here has this solution. We are supposed to find the HCF of this because highest common factor, we want to stack maximum number of burfis in one stack, and it should be the factor of 240 also because badam burfis we have to settle down, and same height we have to settle down kaju burfis also, so that it would be the factor of 130 also. So common factor should be there. So highest common factor will be finding because we want to cover less to less area of the tree. Highest common factor with the help of Euclid division lemma we will be finding, and its factor here is given to be 10. Thank you. Stay home, stay safe. Bye bye.